Sewage sludge combustion plants. Safe use of sewage sludge, ecological and economical at one and the same time. With the thermal utilization of sewage sludge, SBG and RASHGA comply with the legislator's requirements for the environmentally and climate-friendly disposal of sewage sludge. Efficient utilization includes, above all, the energy-related use of the sludges for electricity and heat generation. In addition, phosphorus as an important plant nutrient can be recovered from the sewage sludge ash. In sewage sludge combustion plants, mechanically dewatered sewage sludge from various sewage treatment plants is disposed of. The sewage sludge is delivered by road transport and recorded by a logistics system before the sludge is tipped into the reception bunker of the sewage sludge combustion plant. After unloading of the sludge, the fully automatic crane systems handle further conveying of the sewage sludge. The crane systems clear the tipping points, mix the sludge in the mixing bunker, and fill the conveyor units via a feeding box. The feeding box is the interface between the sewage sludge bunker and the boiler house. From the feeding box, the sewage sludge is fed by means of a moving floor discharge system to the downstream screw conveyors and conveyed into the disc dryers via roller course material separators. In the steam-heated disc dryers, the moisture content of the sewage sludge is reduced from approximately 75% to about 60%. The reduced water content in the sludge will enable to optimize the incineration process and guarantee an autothermal combustion in the fluidized bed incinerator at a temperature range from approximately 900 to 950 degrees Celsius. After drying, the sludge is conveyed via screw conveyors to the fluidized bed combustion system. There, additional sewage sludge in the form of dry granulates can be added and mixed with the partially dried sludge. The fuel mixture is subsequently fed into the furnace via spreaders. In the process, the spreaders ensure even distribution of the sewage sludge over the entire fluidized bed. The fluidized bed consists essentially of a quartz sand filling, and it is fluidized with the primary air in an upward current, which grinds the sludge feed into very fine particles, enabling an even and full combustion. The primary air is introduced below the fluidized bed by means of the fluidizing air fan. In addition, secondary air is injected into the so-called freeboard of the fluidized bed incinerator. Drying of the sewage sludge produces vapors. The vapors are fed, for the purpose of heat recovery, into a tube bundle heat exchanger and are fully condensed. The waste heat can, for example, be used for the production of heat for district heating purposes. Non-condensed vapors are, by means of a fan, injected into the freeboard of the fluidized bed. The hot flue gases leave the fluidized bed furnace through the conical furnace head and are fed into the heat recovery steam generator, arranged downstream. There, the flue gas flows though the vertical boiler passes and cools down on the steam generator and economizer heating surfaces to approximately 180 degrees Celsius. Downstream of the boiler, the fly ash particles entrained in the flue gas stream are separated in a first filter stage. After dedusting, the flue gas is fed into a reactor in which the additives hydrated lime and activated carbon are added. By means of hydrated lime, the acid flue gas constituents such as SO2 are separated. Activated carbon, moreover, binds heavy metals such as mercury. These solids are separated in the second filter stage and removed from the process. A part of this solid flow is again added to the flue gas reactor in order to increase efficiency and to reduce the consumption of the additives. After the second filter stage, the flue gas is fed into a two-stage scrubber system. At the scrubber inlets and outlets, there is a heat transfer system enabling the flue gas to be cooled down before entering the scrubbers and is heated up again downstream of the scrubbers. In the scrubbers, the fine cleaning of the flue gas is carried out in an acidic and an alkaline scrubber stage. Downstream of the scrubber system, the cleaned flue gases leave the process via the stack. The residual materials from the flue gas cleaning system are conveyed pneumatically into silos. The sewage sludge ash from the first filter stage is stored separately from the residual materials of the second filter stage. Hence, the high-quality sewage sludge ash from the first cleaning stage is available for phosphorus recovery. The residues are loaded onto silo vehicles and transported away for landfill.